Hello, my name is Hamza Said and this is my university card. So today I'm going to represent my research titled Frontal Face Reconstruction from Occluded and Side View Images using OccludeGAN. And GAN is basically a generative adversarial network. So in this representation, I'm going to summarize my research aim, methodologies, technical approach, ethical considerations, and key contributions this study makes to the facial recognition technology. So we have introduction and research aim. So facial recognition technology plays a pivotal role in security, biometric verifications, and surveillance applications worldwide. However, existing systems often fail under challenging conditions such as occlusion, poor lighting, and extreme poor variations, typically in real world examples like we have a CCTV footage. So in my research, it aims to address these challenges by developing OccludeGAN, a specialized conditional generative adversarial network that is designed specifically to reconstruct high quality frontal faces from occluded and angled image captured by CCTV. So, by improving face reconstruction capabilities, my study contributes directly to enhancing the reliability of biometric security systems and real-time surveillance. So then we have research objectives. To fulfill my research aim, I established three clear objectives. The first one is to design OccludeGAN and its implementation, leveraging advanced GAN architectures and specifically UNet and patch GAN to accurately reconstruct frontal faces. So in the second step, I generated a novel paired dataset that realistically simulates CCTV conditions, employing strategic methods such as intentional occlusion varied poses and downsampling to mimic low resolution surveillance scenarios. So in the third step, which is the last step, I qualitatively and qualitatively evaluated the performance of OccludeGAN, comparing it rigorously with benchmark architectures like CycleGAN and DCGAN to access improvements in face reconstruction like accuracy, realism, and identity preservation. So these were my three objectives which I used to establish my research aim. So then we have research methodology and data collection. So my research follows an experimental quantitative methodology suited to objectively assess the effectiveness of GAN-based architectures. So I focused on data collection by systematically using synthetic datasets that closely emulate real-world CCTV scenarios. So techniques included intentional degradation, such as downsampling to reduce resolution, application of realistic occlusions, and diverse post adjustment to ensure ecological validity. Carefully processing and augmentation of these datasets were critical for effective training of OccludeGAN and ensuring its applicability to actual surveillance conditions. Then we have technical approach and testing. So my technical approach involves implementing conditional GANs such as explicitly conditioning image generation on critical identity features and pose characteristics. So OccludeGAN utilizes advanced generative architectures like UNet to preserve detailed spatial features and patch GAN discriminators to ensure high frequency realism in generated images. Like for rigorous evaluation, I employed standard quantitative metrics such as structural similarity index, which is SSIM, and then we have mean squared error, which is MSE, and then we have peak signal to noise ratio, which is PSNR. So I use these rigorous evaluations. And additionally, qualitative assessment includes visual inspections for identity preservation and realism. Comparative benchmarking against CycleGAN and DCGAN ensured comprehensive validation of OccludeGAN's improved performance. So then we have some limitations and ethical considerations. So While my study offers significant contributions, it also acknowledges critical limitations, including inherent changes like GAN, training instabilities, potential mode collapse, and the computational demands of high-performance GPU infrastructures. Ethical considerations are integral, addressing concerns around privacy, consent transparency, and potential biases in facial recognition technology. I proactively incorporated stringent ethical standards aligned with regulations such as GDPR, employing anonymized dataset transparency frameworks and bias mitigation techniques. This comprehensive approach ensures responsible innovation, aligning technological advances with societal values and professional integrity. So in the end, we have some research gap and contributions which comes in conclusion. So in conclusion, my research identifies and addresses key knowledge gaps evident in existing studies, specifically limited ecological validity of datasets, insufficient ethical integration, and inconsistent methodological practices. OccludeGAN uniquely contributes by providing a robust technical solution explicitly designed for real-world surveillance conditions, which is coupled with a strong ethical governance framework. So this integration ensures enhanced accuracy, ethical responsibility, and practical reliability. Ultimately, my research bridges technical innovation with critical societal experiment expectations, offering meaningful contributions to facial recognition technology for security and surveillance applications. So that was all about my presentation. Thank you so much.